So how the charge will be shared, what will be the common potential, and what will be the loss in energy when two conductors are connected. So sharing of charge, common potential, and loss in energy. When two conductors or capacitors are, are connected. If two conductors having a different potential, all different potential only, then only there will be flow of charge. Potential is same, no flow, no loss. Okay, so that is understood. So generally it will be given either spherical conductor or capacitor. So suppose these are the two charges, two spherical conductor like this one and other is this is having, okay, this is having plus Q1 charge, this is having plus Q2 charge, and they are connected. What will be? There will be flow of charge? No? There will be flow of charge. Till what?
Potential difference is same.
Yes?
The potential difference is same.
Till they acquire the same potential, and that potential we call common potential. So there will be flow of charge in this case, but net charge will be conserved. Charge is not lost. No, charge can't be created, nor it can be destroyed. So it can be simply transferred from one object to other object. So net charge will be same. So at common potential, amount of charge which it will acquire or amount of charge which it will acquire will not be equal to Q1 and Q2. It will be different. So sometimes it is asked how much charge will be acquired by this, how much charge will be acquired by this. So this is one situation. So what is the net charge here? Net charge Q will be how much? So it will become Q1 plus Q2. Now come to other situation. This is plus Q1, another conductor is having minus Q2 charge. Now they are connected. What will happen? Yes? What will be the net charge? So it will become Q1 plus minus Q2, algebraic sum always. That is Q1 minus Q2. It may come positive, it may come negative. If it is coming positive, that means both will acquire positive charge afterwards. If it is coming negative, that means both will acquire negative charge afterwards. That will depend on which potential is more. Magnitude. If this potential magnitude is more, naturally it will start giving the charge. So both will acquire the same nature charge. It will not happen that this one will having positive charge, this one will having negative charge. That will not happen. Steady state, they both will come at the same potential. So potential is coming plus 2 means This will also having positive charge. This will also having positive charge. Potential is coming minus 3 volt. This is also having negative charge. This is also having negative charge. So this is, so net charge you have to find this way. This is in case of conductor. So what is that? What will be the value of common potential? So this common potential will be net charge over total capacity. Capacity is scalar quantity. We will discuss in case of capacitor also. So that is, so this is Q over C1 plus C2. If this one is at potential V1, this is at potential V2, then what is Q1? C1 V1. What is Q2? C2 V2. Sometimes Q1 will not be given. You will be given this voltage, this voltage. So if this Q1 plus Q2, so always we have to keep in mind, you have to, Q1 plus Q2 means what? You have to consider sign also. That doesn't mean here Q1 is positive, here Q2 is negative, so here added. No. So Q1, whatever algebraic sign is there, that also you have to consider. By C1 plus C2. Or it can be this common potential, generally we write V. So this V may be C1 V1 plus C2 V2 by C1 plus C2. If radius of this one is given, suppose R1 and this is R2, then what will be? This C1 is 4 pi epsilon naught R1. Similarly, C2 is 4 pi epsilon naught R2. Now, when you are asked at equilibrium, at common potential, what will be the charge acquired by this? At common potential or at equilibrium, charge present on first conductor. This Q1 dash will be how much? So C1 into V. Because now potential is not V1, which one earlier it was having. Now its potential has come V. This also has come to V. So V we will find by this way or this way, whatever things are given, and then C1 into V will be the charge present on first conductor at equilibrium, and that on second. This will be C2 into V. Now, during this process, during this sharing of charge, there will always be loss in energy. Because some spark will take place, some heat will, when the charge is flowing through this wire due to resistance. some energy will be converted into heat. Sorry. So how will you calculate loss in energy? So what is the initial energy of the system? That is U1 plus U2. So it is half C1 V1 square plus half C2 V2 square. Or it may be Q1 square over twice C1 plus Q2 square over twice C2. So if charge is given, then by this way. If C and V are given, then by this way. That is the initial energy of the system before connection. This was the energy. Now, so at common potential, what will be the energy of the system? Suppose this we are taking U. Okay. This is U. At common potential at equilibrium, total energy of the system. So it may be half C1 V square plus half C2 V square. Or Q1 dash, Q2 dash. If we have got Q1, Q2 dash, we can find by that way also, no problem. So this will be, that is, V square over 2 will be common and C1 plus C2. Now you will be asked to find loss in energy. This delta U will be U minus U dash. So what was the initial energy and what is the final energy? You will have to subtract this. This has got one final expression. If you are interested, you can derive that, but it is not in syllabus. But these steps you are supposed to know because numericals are asked on these things. So if you are interested, you can do this calculation. So this is U minus U dash. What was the initial energy? Half C1 V1 square plus half C2 V2 square. Now minus half C1 plus C2 V square. In place of V, we can write C1 V1 plus C2 V2 by C1 plus C2 whole square. So 1 will be cancelled. C1 plus C2 and C1 plus C2 whole square. So 1 will be cancelled. That is C1 V1 square plus C2 V2 square minus C1 V1, okay, C1 square V1 square plus C2 square V2 square plus twice C1 C2 V1 V2 by C1 plus C2. Multiplied. So this is cancelled. This is cancelled. C1 equals to count. So V1 square plus V2 square minus twice V1 V2. Positive. V1 is greater than V2 or V2 is greater than V2, V1. No problem. So it is whole square. A square plus B square minus 2AB. So V1 minus V2 whole square or V2 minus V1 whole square. This is always positive. This shows delta U is always positive. That means always there will be loss. Whether your charge is flowing from A to B or B to A, no problem. Always there will be loss in energy. So this delta U is always positive. This is the situation in case of conductor. Same thing, whatever we have derived, same will come in case of capacitor also. The formulas are not different, same formula. Suppose these are the two capacitors. This is plate number 1, this is plate number 2. This is having plus Q1 charge, this is having minus Q1 charge. Other is capacitor is like this, plate number 3, plate number 2. This is plus Q2 charge, minus Q2. Okay. Its capacity C1, its capacity C2. Now, how can we connect these two capacitors so that there is flow of charge? Suppose we are connecting this way. So this is plate number 1, this is plate number 2, this is 3, this is 4. So what will happen? Will there be flow? Will there be flow of charge? Yes? What even all are sleeping or what?
No, sir. Thinking, sir.
Why?
Yes, sir. There will be.
Huh? No response?
There will be.
How many are left? Okay, 12 are there. Only one left. What happened? No response from anyone?
Sir, I
Will there
think
be flow of charge in this case? Just now we have discussed.
yes, sir.
Your problem, Sana.
Yes, sir.
So there will be no flow here.
Hi.
Unless we connect this,
Yes, sir.
then only circuit is complete. Other way is this is plate number 1, this is plate number 2, and we are connected 1 and 3, suppose. This is 3, plate number 4. Okay. So this is now what is the equivalent capacity in this and what is equivalent capacity in this?
That one is series. Parallel, I guess.
Yes. Where is Anmol? Present or absent? Sleeping. Abhinav?
Absent.
No,
Yes,
Abhinav
sir.
was present.
Yes, sir, I'm present.
Yeah, only Shreyas is absent, I think, today. Shreyas is not visible.
Shreyas, yes, sir, Shreyas has not entered the class today.
Anmol, where are you? He, after login, roaming here and there.
So Anmol told that he was not feeling well. Therefore,
How he told?
sir, I called him.
But he is present, I think.
Yeah,
No, he left
sir.
or what?
Yeah, he left the group. Initial
Okay.
few minutes he was online, sir, but then he left the group.
After that left. Okay.
So looks like first one is in the series and second one is in the parallel connection, but we have not provided the potential difference.
Okay, so here both are in parallel. Suppose this is the point A, this is point B, this is point C. How they are connected? So this is plate number 1, plate number 2. Now this, it is connected to the C and A are same. C, or you can say A only, because it is connected by Y. So where is plate number 3? This is point A, this is your point B. Plate number 3 is connected to B. So here is 3. And here is 4. See the difference. So in this case, net charge is how much? Q1 minus Q2. Here, this positive plate and this negative plate is connected. plus minus Q2. But here net charge Q is Q1 plus Q2. This is the difference. So when doing the problem with parallel plate capacitor, you will be given both positive plate are connected together, or plate number 1 and 3 are connected, or plate number 2 and 3 are connected, like that it will be given. So you have to think how they are connected. So in this case, when positive plate is connected to negative plate, net charge will be like this. If Q2 is more, naturally net charge will become negative only. But C will be in both the cases C1 plus C2 only. Here also C1 plus C2 because they are connected in parallel. So net capacity will be in both the cases C1 plus C2. Got the point? After that, all the formulas same. So whatever formula we have derived for conductor, all are applicable in case of capacitor also. Because there also it was same. So this can be C1 V1 plus C2 V2 if you are given potential like that. So this also same C1 V1 plus minus of C2 V2 it will come. Because positive plate connected to negative plate. So this way we can find what is the net charge, what is the common potential. Same formula will come. So V will be same whether this is this one or that one. So V formula will be same. Q1 plus Q2 by Q1 plus C2. C1 V1 plus C2 V2. Like that what we have done. Q1 plus C2. Okay. So we'll leave up to here. Tomorrow you will have 2 period continuous, no? Yes.
Sir.
What do you want?
Yes, sir.
Yes.
The
Then we shall
continuous only is
start.
good.
We shall start your class at 11:10. So 10:40 to 11:10 you got the break, or 10:25 you will be finished second period. Understood? So your break will be from 10:25 to 11:10.
Okay.
Will it be okay?
Yeah.
Because I have got some other work, so that's why I am telling. So from
Okay.
11:10 we will start till 12:20.
Okay, sir.
20-minute class will be there. So 11:10 to 12:20. After that, you have got the class at 12:40. So 20-minute gap that side also.
Thank you, sir.
Okay.
Yes, sir. Thank you.
Thank you.